Hi there guys, welcome back to another one of our videos, and there's only me today, no Rhiannon for this one. We're going to be doing a screencast where we are looking at Autodesk Tinkercad. So Tinkercad is a free tool. Go to www.tinkercad.com, sign up for your account here, and you are going to be able to begin building things. So it's an online simulator of your Arduino. So if you haven't yet got an Arduino, maybe you don't have the budget to get one, there's no reason why you can't follow along with our tutorials using a virtual world. And even if you do have a real Arduino, this is a great way for you to prototype and work out your circuits and your code and run the simulations before you build the actual one. So it's a great design tool. So go over to tinkercad.com, and once you're in there, we're going to create a circuit. Once that loads, you're going to get a bunch of options down the right side here, and we're going to search for Arduino. And they actually have a really nice setup where the Arduino already is wired up with the breadboard. So that saves you a little bit of time. Once we've got that, we're going to make a real basic circuit, and we're going to add a LED to this. So we would grab an LED and we'll stick that on here. You can choose the color of it. We'll go with a blue one. And then we'll add a resistor. So we'll drop our resistor into here, connecting the positive to the anode as usual. We'll make the resistance of this 200 ohms. And then we'll put in our output, which would be there, and we'll turn that to black. So we stick with our usual convention. And now if you press the Start Simulation button, it's going to power on, and you'll see we've got our flashing light, we've got the on, and we've got the power coming into our breadboard, and our LED is on. Now if you've seen some of our videos with our actual Arduino, you'll know that the flashing light here is actually tied to pin number 13. So if we wanted to make this LED flash in our simulator here, we'll just press stop for a moment. I'm going to move the LED over here, and we'll bridge that with the resistor, and then we will make a new power out on that side, and we'll make a power in coming to the resistor, which is going to come from pin number 13. And to keep things tidy, rather than having it in a straight line, we'll connect it like so. And of course we need to change this to red because that's our positive. And so now when we start the simulation, you'll see our LED flashes in time with the IO pin number 13 there. So you can build, as I said, an actual digital version of your real life kit. And then you can also begin to add code. So there's ways of building the code using code blocks, or you can do text. I personally prefer the text because I think you learn more about the underlying code, but the code blocks are a great way for you to get introduction to how to build the logic of your circuit. So we'll just go back over to one that I made earlier. So here we have one, and we will open this up. So in this circuit here, you'll see we have a switch and we have a LED. Now in this case, the switch is not in series to the LED, meaning that the switch is not actually directly controlling the power that goes there. But when we run this, if we push the switch, the light comes on and the light goes off. But this is not happening through a direct electrical connection. This is happening through software. If you look, our switch here is connected to pin number 2, and our LED is connected to pin number 3. So they are not electrically connected. It's not like a series circuit where you would have the power coming in, going to the switch, coming out of the other side of the switch, and going to the input of the LED. So how is this working? Well, we are using the microprocessor and a very basic program. So what we have here is our program that is controlling this. So let me explain this program to you. So first of all, our initial switch state is going to be 0. So that's the condition of our switch. We're going to say it is 0. So we've created a variable. We've initialized a variable called switch state, and we've set it to 0. And then we've defined our pins here. So we have pin mode, LED built in, output. So the built-in LED, which is the orange LED that flashes when we turn on, is already set to an output. Okay. Pin number 2 is an input. That's because pin number 2 is connected to our switch. So we are going to be using pin number 2 as an input. And then pin mode 3 is an output. That's the output to our LED. So think of it like this. On pin number 2, the computer is going to be listening for when the switch is closed. It's going to receive a signal. And when it senses that that switch is closed, it will send a signal to pin number 3 to turn on and send power to there. Now we have a loop. So in the setup, this is run once, and everything inside of the loop will continuously run. So what we're doing here is we're reading the switch state. So the switch state, which we defined at the beginning, is going to be defined by reading the digital input, which is either 0 or 1, open or closed, on pin number 2. So pin number 2 connected to the switch state will be defined by that. So initial switch state, 0, that means that the switch is not pressed. When the switch gets pressed, we're going to then send a signal to pin number 2, which will turn it high. So if switch state is high, then we want to turn our LED pin, which is pin number 3, to high. So you'll see here, if switch state is equal to high, the digital write to pin number 3 will also be high. So we will turn pin number 3 high to match the state. So if the switch is on, we turn on the LED. If the switch state is low, then our digital write to pin number 3 will be low and the switch is off. So basically, when we push the switch, signal comes to pin number 2 and a signal goes out to the LED. So that, in essence, is a really, really simple code for a very simple circuit. Now the same outcome can be achieved with no code by putting the switch in series to the LED. And we'll explore that in our next video.